Hello everyone. I've had a few questions about having to find the equation of a tangent to a curve. A few people seem to be having some problems with this type of questions. So I'm just going to quickly go through the problem question that I'd given you as practice for the test. So you'll find this in the problem set that I've given you on Moodle. So just going through it quickly, what we have here is an equation to the tangent that's required. That's to the curve to y equals x to the power 3 minus 5. How do we go about finding the equation at this particular point at 4 minus 1? Okay, so what I'll do is I'll take you through the process to show you exactly the steps you need to take to find it. First, the first thing you got to remember is that the tangent at any point, or the gradient of the tangent at any point, is given by the derivative of the function. So in this case it is y equals x3 minus 5. So to find the gradient of the tangent, you would differentiate this function, and then at x equal to 1 you would find the you'd find the gradient. So just going through this, the first thing I put up is the form of the equation of the tangent. So what we have is the form that it takes is y minus b over x minus a, which is equal to y, or the derivative of y at point A. So in this case, what is point A? If we look at this, is the point that we've given. Now this here is of the form A, B. Okay, so A is the x value and B is the y point. If we were only given, let's say we were only given x equal to 1, how would we find point B? In this case, it's been made easy for us. We've already been given that point. But if we didn't have that point, all we'd have to do is substitute x equal to 1 into the equation here. So what we'd have is, I just make the substitution over here. What you'd have is y is equal to 1 cubed minus 5, which gives you minus 4, which is essentially the value of b that we've been given. Okay, that value there. So there's no big loss if we didn't have that value, but we already have it, so it's easy, saves us having to do a calculation like that. Okay, so looking at the form of the equation to the tangent, what do we have? We already have points A and B. All we need now is the gradient at point A. So how do we find the gradient? We differentiate the equation of the curve. So in this case, dy dx is equal to 3x squared. Okay, so that's the derivative. At x equal to 1, the derivative is equal to 1, just for completeness, which is equal to 3. Okay, so now we know this value here. Okay, so just clearing this up a little bit. So now we know that. So it's just a matter of substituting the values that we have. So we have y minus 4, which is the value of b, over x minus 1, which was the value of a, is equal to 3. Okay, so that's getting into a form that we might be able to get the equation of the curve, equation of the tangent in terms of y. Okay, so now we have, if we just take that out, y plus 4 is equal to 3 x minus 1. Okay. Y is equal to 3x minus 3 minus 4. End up getting 3x minus 7, which is the equation of the tangent that we were looking for. Okay, y equals 3x minus 7. Just looking at the problem again. So we had this form here for the equation. We knew a and b. To find y prime or dy dx, whatever you'd like to call it, the first derivative, we differentiated the function, and then we substituted 1 in at the point at which we needed the gradient. Okay, and then from that we just simplified to get the equation of the gradient. Now just for completeness, let's see what this function actually looks like. So what I'll do is I'll just get the calculator so we can graph it. Okay, so if we just have a look at that, I'll write up that function y equals x to the 3 minus 5. Okay, so now I've got that function there. I'll graph it. That's what the plot looks like. The next thing we need is the tangent at the point y equals to 1. So using this, I can draw a tangent. Something didn't quite work. I'll just give that another quick go. Draw a tangent. Okay, we need the point, so it's looking for the point at x equal to 1. Okay, so that's what we need at x equal to 1. And there's the equation of the tangent at x equal to 1, which is essentially what we've got here. Y equals to 3x minus 7, y equals 3x minus 7, and that's the curve. Y equals x to the power of 3 minus 5, and that's the tangent at point x equals to 1. Okay, so as you can see, when x equals to 1, y here most likely is not most likely, but it should equal to minus 4 just by looking at this graph. Okay, so there you have it. This is the equation of the tangent. The next question you have is at what point does the tangent cross the x-axis? In other words, what's this point here? At what point does it cross the x-axis or the x-intercept? Okay, now again, you know that to find the x-intercept, what you have to do, the x-intercept occurs when y is equal to 0. So what we have there is as soon as I get my pen back, it is, oops, don't like that, let's get rid of that. Okay, so the point at which it crosses the x-axis, which is, so the x intercept, still trying to get used to this pen, that is very messy. I'm gonna have to get rid of that. Okay, I'll try that one more time. Okay, the x intercept occurs at y equal to 0, so we make y equal to 0 here. What we've got is 0 to 3 minus 7. Okay, 7 3 x. So just from here, x is equal to 7 on 3. Okay, so from there we should be able to see that, bringing that back in, it's that point there, 7 on 3 at which it intersects the x-axis. Okay, so what we have there is both our solutions that the questions asked for. Okay, the question asked for what's the equation of the tangent. We have worked that one out. We've said that's the equation of the tangent, and then we found the x-intercept, or the point at which it crosses the x-axis, which is 7 on 3. If you really wanted, for completeness, the coordinates you specify is 7 on 3, 0. Okay, and that would be your answer.